Okay, hello everyone, and welcome. Guys, this is the first day of material, okay? We're going to solve one-step and two-step equations. Now listen, in the video, I have to move kind of fast because it has to be less than 10 minutes or to upload it. But you can always stop it and look at it, okay? Again, this should be review, guys. We're going to start with a kind of an algebra review, so helping you guys to solve for x. So again, today's objective is to solve one- and two-step algebraic equations. We're going to do one- and two-steppers together the same day. The essential question of the day, and you're going to need this for the homework check. All right, what does it mean to solve for x in an algebraic equation? I mean, what does it mean to solve for x? What does that mean? All right, the solution of an equation, that's one of your vocabulary words here today. It's the value or values of a variable which make the equation true. All right, what value of the variable makes the equation true? Now, sometimes the solution is a number, and sometimes we solve one variable in terms of other variables. But y'all, look, we won't do that until the end of this unit, okay? Today, we're just going to find a number. Guys, again, a linear equation, it can have one solution, and we'll deal with that a lot, where it has one solution. But it could have infinite solutions. If you get to the end, like this middle one right here, and there's a true statement there, x equals x, yeah, x does equal x. It always equals x. So it doesn't matter what value of x you put in there, this equation is always true. The original equation is always true. There are infinite solutions. It doesn't matter what you put in there for x. All right. However, this last one, it has no solution. When you subtract 8x from each side, it just disappears. You end up with 6 equals 7. That's not true, obviously. There is no value of x which makes this equation true. It has no solution. Okay? We'll look more at that. Guys, we use the properties of equality to solve an equation, guys, by isolating the variable on one side of the equal sign. All right, that's what it means to solve. Isolate the variable on one side of the equal sign. These are the properties of equality. All right, we're going to use the first 4 in particular: add, subtract, multiply, divide. And then you can look at those later if you'd like. Guys, in order to get the variable alone on one side, we use what's called inverse operations. That's another vocabulary word today. And operations that undo one another. You know, addition and subtraction are inverse operations. Multiplication and division are inverse operations. Guys, remember when you perform the same operation on both sides, make sure that you do that to keep the equation in balance. So if you subtract 8 from one side, you subtract 8 from the other side. All right, perform the same operation on both sides of the equal sign to keep it in balance. Again, you all have done this type of thing before. Again, there's 4 basic types of one-step linear equations, and each one represents the 4 basic arithmetic operations: add, subtract, multiply, divide. All right, these are the 4 types of one-step equations. They're relatively simple. And we'll look at some of those today, too. We're also going to look at 2 steps. All right, I always say if you can do a 2-stepper, you can do a 1-stepper. All right, 2-step equations, you first undo any addition or subtraction, and then you undo multiplication or division. That's a classic 2-step equation. It's linear. Guys, remember that usually a linear equation that you'll be working with has one solution. But sometimes it's got, infinite solutions, or sometimes it has no solution. All right, guys. Next, you can look at the homework check. We'll do it in class. Okay, you can complete it at home, though. I think I have it open. Guys, there's 3 vocabulary words or phrases that you'll need those today, too. Solution of an equation, properties of equality, and inverse operations. All right, that's it. It's a shorter video today. All right, thanks.